Hello. So this is question number 4 in homework 4, and I thought this is a straightforward question, but it seems like many of you did not understand the main point of this question. So what I wanted to say here is that x is an endogenous variable, excuse me, put it this way. So x is exogenous. So x itself has no problem. But suppose that we happen to have another variable, z, which is also exogenous, but it is not directly included in this regression. So already we have x, which is exogenous, so we don't need any instrument, but we just want to see if additional exogeneity assumption may help or not. It may help, but actually now we know the conclusion. Conclusion is no. So we will study why and if it's actually not useful at all. Okay. So first question is to set up a triangular equations model. So triangle. When I search on Google, you have to find a triangular simultaneous equations model. So then you will find many literature, and it means these equations. So triangular simultaneous equations model usually imply the relationship between outcome and endogenous variable, and then endogenous variable on instrument. In this case, as we assumed there are two exogenous variables, we try these two guys. Actually, as I said, we don't need to, because already x is uncorrelated with epsilon, but we just try to see if there is any benefit, any additional gain out of including z. So, and then what we want to show here is, in the question, I want to show that gamma is 1 and delta is 0. So even if you regress on x and another variable, as long as you include x itself, another variable is meaningless because its coefficient is always 0. No matter what this is, always, simply gamma is 1 and there is no residual, no other variable. So all the other guys simply 0. I'm going to show that. And then if this is true, then obviously the fitted value is x itself. And we see that gamma and delta are given this way. Calculate it's this, by the way. V is the vector of x and z at the same time, and then we are to show gamma equals to 1 and delta equals to 0. You have to show that you have to calculate its inverse by algebra. Just do the algebra. Pretty simple, 2 by 2 matrix inverse, and then multiply that to another factor, and then you are going to get this result. So canceled out, and in the end you have 1 and 0. So this is not much difficult, not difficult at all. Just if you understand the intention of the question correctly, it's pretty much straightforward. Again, what I want to do here is I want to instrument x on exogenous variables, but the exogenous variable includes x itself. So we want to see if there is any additional gain out of additional instrument, but there is nothing because you don't need to. Its coefficient is always 0 by this calculation. Another problem in many of your answers, many of you have wrote down very simple model like this. Many of you have done this way up to this point, and suddenly, actually, if you write this answer, the main point here is to say this and then do some algebra like this, right? It's just an algebraic question, but but it's hard to see why. But some of you, many of you, just do not say anything why, but just say you write down the equations like this. The model is given by this, and just write down some very simple, obvious sentences, and then as a result or so, therefore the fit value for x is x. But I don't understand why suddenly you have the result. I'm telling you, you don't need to worry about your grade at all. Your grade means nothing. So if you don't know if you don't have any idea why it is it, then say that. If you just do not write down your work and just say the result, actually I'm telling you the result. You know, usually the question is to show something. This means I want to help you. I want to give you the guide, what you want to show. So this is just a guide, and I'm not asking you to answer this. So when I say show something, you have to show that. You have to explain why you have that result. But many of you just don't say why, but say the result. But logically doesn't make any sense. So it's okay. I understand. There may be two reasons. First, you believe that it is obvious and it is trivial. But actually, I don't understand why that is trivial. To me, what you say is not trivial, not obvious at all. So like this, to you, is it obvious? If you write this, can you see it's 1 and 0? To me, it's not obvious. And then you have to explain why. So then when you write your answer, like not in this course, but in general, and if you think something is obvious, then think that again and just try to explain a little more and see if actually that is obvious. Second, the second reason that I could imagine is that you may want to pretend as if you know something. If that's true, if that's the case, if you want to pretend, you failed. You are just not saying anything, but being quiet doesn't mean you are. You look right. So I understand you don't write anything wrong. That is good, but you don't need to pretend you know that. Maybe later, but I understand it is important to write something as if you know the truth. That is important. It's a writing skill. But then, even in terms of the writing skill, not saying anything about the reason why you get that is not a good idea. You have to say something as if you know that. But most of you fail to do that. Just saying nothing is not a way to pretend. So it's like, you see ostrich effect. Like ostriches, like when they try to hide, they only hide their head. If they close their eyes, if they put their heads in a bush, then they believe they are hidden, like because they don't see anything. They think they are in the bush, but actually only their head in the bush, but everyone else can see where the ostrich is. It's like that. You believe you are not saying something wrong, but not saying something means you don't know anything. So please try hard, or just reveal you don't know that. That's better, and don't waste your time by writing something obvious, something trivial, right? Okay, but by the way, I'm not saying that your effort is worthless. I value your effort if you really made your effort to do your best, but I don't know. I cannot tell. That's the problem. I cannot tell if that's your best or if you are pretending. So I cannot tell what's the case. So please, if you don't know something, but unfortunately the semester is over. Okay, just I hope so. Never mind. And in second question, moment function. Now the first step is fitted value approach, and in the fitted value approach, additional instrument does not help. In the moment function approach, we should get the same result. And here, so moment is given by two. I forgot this. So in this part, in the fitted value approach, you may also use the theory of linear projection here. So it is from the linear algebra again. You are projecting X onto a linear space generated by V. V is X and Z. So what you have to show here is, if you show X belongs to the linear space, then automatically linear projection onto that space is X itself. That's what we are doing here. And this, if you write your rationale in this way, I would say it is obvious, right? This statement, this rationale can be acceptable. It may be acceptable. So you have to say at least something like this, right? And second part B, the moment function is given by two instruments. We use two exogeneity assumptions on X and Z, and nothing is special. It's exactly the same as what we have done. And this is Vi is here, and the variance of the moment is given by sigma squared V prime, and the optimal weighting matrix is inverse of this, and it just needs to be proportional, because constant multiplying a constant to this weight does not change the minimization. So we are going to ignore the positive constant sigma squared. This part does not matter in your minimization. So we are going to take this part, and which is easily estimated by sample average. The population mean is estimated by this. So as a result, you do not need two steps. It does not require an estimator of beta. Beta is unnecessary to calculate the optimal weighting matrix. So you don't need to use two-step estimator. But even if you use two-step method to estimate sigma squared, that is not wrong, but just it's unnecessary. Okay, that's moment condition approach. And here, based on this, and we are going to use the matrix notation to solve out the GMM estimator. The matrix notation can be written in this way. Check the dimension. Calligraphic V is n by 2, y is n by 1, x is n by 1, beta is 1 by 1. So as a result, V prime y minus x beta as a whole is 2 by 1 vector, which is two moment conditions. And this part, summation of V prime can be written in this way. It is again 2 by 2. I forgot to write inverse of it, of course. I forgot to denote the inverse. And then you check the dimension by yourself. And then the criterion function is given by this simple form. 1 over n is cancelled out, so this and this cancelled out by when you take inverse, and as in the end you have only 1 over n. And this part is the weighting matrix, and the other part is the moment conditions. And as you can see, combined with V and V prime, you have the projection matrix here. Like this happens only when you use the optimal weighting matrix V prime V inverse. And then you know this is the projection matrix. Now we want to show that the result is consistent, equivalent to the OLS. There are many different approaches. You may use its first order condition to show the result is the same as the OLS estimator. But what I'm going to do here is I will just expand the criterion function itself. If you expand it, we have y square term, x square term, and cross product term. And we are going to use the properties of projection matrices. Because projection matrix is symmetric, we used this result. Like you may take transpose of this guy to get this. Transpose is the same because this is 1 by 1 scalar. So transposing a scalar does not make any difference, and that is also possible because this guy is the same. This guy is symmetric. I mean, if you take transpose, this guy should be the same. And also, we know in the question I explained, the projection of x on V is also x, the same x itself, and then we have this part can be written in this way, and that means it's x prime x. Actually, you don't need to use idempotentness. So anyhow, excuse me. Okay, so you have this, and then in the end, the criterion matrix, criterion function here can be written as a quadratic form. So combine, so this guy becomes this, and this guy disappears like this. And then here, these terms together with y prime y can be simplified to a quadratic form. And then the difference between this and this can be separated out, and we know that this term has no effect on the minimization because it does not depend on beta, so it is just adding a constant. Adding a constant does not change your minimization problem, right? So this part has no effect on the minimization, so basically you are minimizing these guys over beta. So, and this format, this criterion function is exactly what the OLS minimizes. So OLS estimator is what you get in the end. So that's how you see, you can prove the equivalence. So this is just one possible way. You may just calculate the closed form solution for beta, or and see the equivalence, or you may just derive the first order condition and show the first order condition is equivalent to the OLS, and then you can show that I'm asking you to derive the closed form solution. So you have to derive the closed form solution, but just I'm showing you there is an alternative way to do that. Okay, this is the end of homework 4. I hope it helped, and I apologize again because the question number 2 and 3 were not ideal questions, so they are very dirty and not good. They were not good. Sorry about that, but still I believe you may learn something out of them. So So I hope they help. Okay, see you later. Bye.